Hello, I'm David Mileto, and this is a functional demonstration before flight of the IMU, or the BNO 055 9DOF sensor. So, real quick, you can see the orientation being updated as I move the IMU. And then it stabilizes when it's still. Here's the code. I'm using Arduino Free RTOS and the Adafruit libraries for the IMU. Here we declare the wrapper class for the sensor, defining its specific type and I2C address. Here we're forward declaring the task code in a prototype. In our setup, we're starting up the serial class, initializing the device, and then creating the task to print orientation. Class name is PO. Task stack size is 512. I'm passing the address to the BNO class wrapper. I'm casting it as a void. Priorities 2, which doesn't really matter right now, and null, I forget what that is. Task handle? Okay, I'm not sure. In any case, at this point, the scheduler takes over and starts running the task. We do nothing in the void loop, or do nothing in the loop. And here we start our task. We have our parameters in here. I think this is so it doesn't get optimized out. We're actually getting our parameters. I have an LED on here just so I know that the task is actually running. It gives me some feedback. Declaring an event on the stack. I'm casting PV parameters back into an Adafruit pointer. Right here. And LED state, I'm just toggling it with this thing. And here we have the permanent loop for the task. First things first, I'm getting the event from the sensor and printing that out to the serial console and toggling the LED and printing it, updating it. Down here, we're delaying the task by the minimum sample rate, the minimum sample rate, and based on milliseconds. And that is the program. Now, okay, here's another little quick pre-flight checkout. So, I just wanted to show you I've got the Arduino down here on the bottom of the drone. I don't know if you can see that just right, but it's there. And it's coming into the back of my Raspberry Pi right over here. And the Raspberry Pi will be beaming it down via SSH to my host. And I'll be able to see that orientation readout on my laptop. This is a demonstration of my drone flying while sending out orientation via Wi-Fi through the Telnet protocol. So here we're starting up a PuTTY session, and we're not going to use SSH. Instead, we're going to use the Telnet protocol. I've bound my Arduino. Arduino is sending UART messages to the Raspberry Pi. The Raspberry Pi reads the Arduino serial on the device TTY ACM0, and I've already set up the Pi so that ACM0, TTY ACM0 is bound to socket on socket with port 50,001. So using the tail nut, port number 50,001, we'll open that. Now it's streaming locally. So we'll turn on the drone and hopefully get acceleration updates. Make sure you can see the drone. Another perfect land.